Welcome! In this series of videos, we will look at software add-ons for the PowerBasic Windows compiler. Today we will look at using the MyLittle custom grid without the use of SQL Tools or SQL Server to speed up your application development. In the previous videos, we demonstrated a PowerBasic Windows application, and within this Windows application it had a dialog on which there was a MyLittle custom grid control. Both the configuration for the grid and the data within the grid was coming from Microsoft SQL Server Express. However, the problem for those of you following these videos is that since the SQL Tools which we use to access SQL Server Express is a purchased set of libraries, then without purchasing them you would not be able to actually either compile or run the code. So I thought there must be a way of actually changing an application to have the configuration information and the data which appears on grids coming from somewhere other than SQL Server. I also wanted to do this by changing as few lines of code as possible in our source applications, so you could quite easily switch between a local dataset and a dataset coming from SQL Server. So let's look at the code to see how we can achieve that. This is the source code for our MyLittle demo. Now in here, at the beginning of the code are all the libraries we're including. One of these libraries is the SQL Tools library. So if we comment out the SQL Tools library, and we also comment out the generic SQL Functions library. This is the library we use to call everything within the SQL Tools libraries. I've included two additional libraries in here, the PB Common Windows library, which we've covered before, and a new generic CDEF Functions library. If we comment these two in and leave these two out, then if we run the application now, so commenting out these three libraries has allowed us to break the link between our application and SQL Server without changing any of the code within the application. And it still has brought back from somewhere the configuration of the grid. What we're going to look at now is where this comes from and how we achieved it. Taking this approach will allow you all to compile this application and try it for yourself. So let's look at the new library we've created, the generic CDEF Functions library. This library includes two other libraries, and we're using the include once command to make sure these libraries are only included once because they may well have been called already. I'm using this library to replicate some of the constants and some dummy functions that would normally be called within the SQL Tools library to convince our calling application that everything is well. And there are also a number of other functions in here which we will cover as we get to them. So in our main application, the first function that is actually called when your application runs is the pbmain. The getXMLValues function is the one that reads our XML file, the DB server XML. This normally tells the application where the database is, what the name of the database is, and the server that hosts that database. Now I'm leaving this XML here, even though we're not actually going to be doing any connecting to the database. But it means it's less changes to make in your code. So for the other SQL Tools functions, SQL Authorize, SQL Initialize, we've effectively duplicated these within our new library. These functions do nothing apart from return the success constant, which is what our application is expecting. We make no connection or attempt to connect to SQL Server at all. The next key function is our read app form grid definitions. This is the function which will return an array which was normally returned from SQL Server. This is a fairly long function, but it does provide us with the array which is going to feed back to the main application. This array contains all the configuration information for the grids, the forms, and the tabs on MyLittle within the application. As I've said in previous videos, the system is set up so that your application can have many forms, many grids on a form, and many tabs on the grids within those forms. So where are we actually getting this information from? Well, in our application folder, our sample app, there's a CDEF config subdirectory. if we have a look at that, in here are a series of configuration files. Now these are equivalent to the store procedures that were normally called in the SQL Server database. For example, there was a store procedure called get all applications, and this returned 3 rows of information, a header row and 2 data rows. In this case, this is the name of our executables. So the system is currently configured to support 2 different executables. And if we have a look at the forms, we'll see there are 2 get forms in app, one with a 1 after it and one with a 1001. That number refers to the application number, which is stored in this first file. So when the application loads, it first checks to see, is the application it's running mentioned in this file? In this case, it's MLG demo.exe, and its ID number is 1001. So the next stage is to look for the get all forms in app 1001. And then it looks to see there is only one form configured for this particular application. And it then looks down to see, give me all the grids in the form for that one, which again is 1001, 1001. And it tells us there is only one grid, which is also numbered 1001. And we get all the tabs in the grid, and there are 2 tabs, one for data and one for departments. And to get the tab references, it then goes down to the next file and pulls this back. And this is what will appear on your screen. So this allows the application to work completely locally, not connected to the internet, not connected to the SQL Server database, but still functional. However, our application is not displaying any data. The data, of course, is held in SQL Server. So how can we convince the application that there is some data? Well, in our CDF functions library, there are a number of functions which are used to pull back information which would normally come from the SQL Server database. For example, get generic data. The get generic data function merely passes on to the get SQL result set, and the SQL result set is aimed towards the files rather than the database. Now, there are a number of what would have been store procedures mentioned specifically, and they call specific functions, to perform specific tasks. However, down at the end here, if we get down this far, for everything else, so if we pass it the name of a store procedure that it doesn't know about, then it will attempt to read that as a file, and then it will return that as an array. So all we need to do to get this application to pull back data is to create a file, a config file, with the data that would normally be returned from the store procedure. So if we have a look at my little grid demo, we'll see in here, in the initialization section of the callback function, the event handler, there are 2 store procedures which are called to get the data onto the grid. There's the SPR get user list, and there's the SPR get department list. So how can we turn the data that's in that database into a flat text file that we can read without changing any other code? Well, let's have a look at SQL Server. So here we are in SQL Server Management Studio. In executing the SPR get user list store procedure, we get this data returned. And this is returning a couple of thousand rows. Now there's an easy way to actually get this into a format we want. We will copy the entire output with the headers. And then we'll go back to our main application. And in here, we're going to create a new spreadsheet. Now I'm using OpenOffice here, but you can use Excel just as well. So if I just paste the information in, there's our data. Now we want to convert this effectively to a CSV file, but pipe delimited rather than comma delimited. This can quite easily be done by doing a save as. We'll pick CSV from the list, we'll click save, we'll keep the current format, and we'll change the field delimiter to a pipe character. And that's it saved. Now we can discard the spreadsheet, and in our CSV file we want to rename this file for what we're actually calling. Now we're attempting to get an SPR get user list. So we'll copy that name and we will rename that like so. So we now have a file called SPR get user list CFG. So if we try running our application now, we'll find it has indeed pulled back all the information from the flat text file as if it were a database. Quite happily. Now it hasn't populated the departments one yet because we need to do exactly the same task with that. We're finished with the spreadsheet, and we will take the name of what would have been a store procedure and we will rename that. And we'll put CFG at the end. So we've now got a department list which has our departments in it. So we now try running our application again, and remember we haven't changed any code within the application. We now get the departments, and our drop down list to allow us to pick another department is still functional, just as it was when we were pulling the information back from SQL Server. So what we've managed to achieve in this short session is we've broken the link between our application and SQL Server. This application will now run standalone and can be used to demonstrate to a user what you can do to build up your application quite quickly. So this amended library I've put in place to allow you to actually run these yourself is very new, so it's probably likely to have a few bugs in it, which we will cover in later videos. But that's it for today. Thank you for watching.